So welcome back to another episode of Learning by Doing OpenFOAM. Today we're going to talk about another interesting topic, I would say, and namely we're going to talk about implementing our own turbulence model in OpenFOAM. Just like the tradition of these video series, the core idea of making this video was basically inspired by a question in a thread of CFD online. So without further ado, let's jump into the question. So it was on 25th of March, a user called Filippo says basically vmake doesn't compile a new turbulence model. This is my first post. Congratulations. I'm writing my master thesis in implementation of a new turbulence model. Best of luck with that. I have compiled OpenFOAM 12 in my home directory, and I tried to compile an existing turbulence model called myKepsilon by watching the following YouTube tutorial. By the way, I haven't watched this one. The result is the same as the video, and the compiler doesn't give me any error, but the compilation failed. Okay. In fact, when I type myKepsilon-help, the bash responds with command not found. And in addition, myKepsilon folder after the compilation waits only 120 kilobytes, while order of magnitude should be around like 2 megabytes. And he adds, I had already tried to compile the same customized turbulence model with OpenFOAM 10 installed in op directory. Somehow I feel like Filippo has this biased sort of reasoning or biased opinion that probably installing your OpenFOAM in a different directory might affect what he's trying to do in this case, which is not the case at all. It shouldn't be the case at all. But anyways, so he mentions that I really appreciate your help, and he also attaches the compilation. And indeed, this is like the output of vmake, and it says error.jpg, but I don't see any errors happening in the compilation step and nor in the linking step at all. So it seems like the compilation is completely fine, but there is still an error. So let's go further. A couple of days later on 27th, Tobermory says, I'm not sure what you expected to see whenever you wanted to try typing this myKepsilon-help. You can try it with kepsilon, which is already an existing turbulence model in OpenFOAM, and you will get the same result anyway. Remember, you are compiling a turbulence model and not a solver. That's a valid point. Your first check should be whether it actually generated any output for you, and look at the path at the end of the screenshot you attached and see whether the .so library exists in there or not. If yes, then all is okay. Same day, Filippo comes back and says .so has been generated and it waits only 16 kilobytes, and I tried to run a simple test case and I got the following error. And then you see that we have this DL open error, and then we have an undefined symbol, and this is like the mangled name you see is just a bunch of garbage, and then we have in between we have compressible momentum transport model. And then later it says that foam fatal error because unknown RAS model, myKepsilon, and the valid ones are these 19 ones, and myKepsilon is not one of them. So my first impression is that from the picture that Filippo sent, there's no compilation error, but at least he's getting an error on runtime, and it seems like the RAS model that he compiled, the turbulence model he compiled, is not properly added to the runtime selection table. That's my guess. And then you see that the error happens at rasmodel.c at line 155. You can check it. That's exactly the function that it basically retrieves the keyword of rasmodel from that dictionary turbulence properties, and then it tries to check it against the table. If it exists, it's fine, and the simulation runs. If it's not, then it's going to basically dump out this error for you. Then he says, I modified the momentum transport and control dict, and they look like this. He added here as the model myKepsilon. And in control dict, he basically didn't change anything other than adding these libs as the name of the library that he wanted to compile. A couple of days later, on 29th, Toby comes, hi, first, we do have code tags to make clear text passages. So what he means here is basically using those brackets code, and then in the end, you can say brackets code backslash or slash. I never learned it. But anyways, that's basically printing these code line things in a nice manner. Second, as already mentioned, you probably compile a library, not an application, hence typing myKepsilon doesn't make sense at all. This is the point that Tobermory also made. Third, show us your compilation output. I believe that in the first sort of post, he already showed it, and I haven't seen any errors, at least, not in compilation, not in linking. Fourth, I didn't check the video on YouTube, but the lib that you are trying to compile is built for OpenFOAM 12 or any other version. And then a couple of days later, again, Filippo comes back, thanks Toby, I solved the problem by changing some lines in make and options. And then I checked the previous libs and they were built for OpenFOAM 12. And it helped me a lot following this article. And this is sort of a document. This is affiliated to Chalmers University in Sweden. It's a nice, well-written document. Yeah. And anyways, he said the problem was probably changing some lines in make and options. Okay. We try to recreate whatever problem he was facing, and let's see whether we get sort of at least a similar scenario, if we can get it. So, but wait a second. So now you would basically say that what the heck, what's the purpose of this video then? We have a problem, articulated well, and then some people responded, and finally Filippo comes and says that, hey, the problem is solved, and this document basically helps. So here's a disclaimer. I can name basically 2 reasons that you need to basically watch and continue watching the rest of this video. The first one is, usually in documents like this, and I read like not the whole document, but the most important parts that are relevant to this video. And I read those parts, and there is no explanation or interpretation why we do things the way we do things. So if you want to know that, or that is a sufficient enough reason for you to follow this video, then be my guest. The second argument I can bring here is that usually in these types of videos that I'm making, these educational sort of videos, I try to basically give a sense of sort of intuition, or like trying to play the role of a detective, sort of trying to, work around and find my way. Let's say if I don't have any knowledge about OpenFOAM, I want to use some tools in the terminal and stuff like that to basically find my way and figure out what is the cause of my problems, and then find a solution or a remedy for that. And usually in these scenarios, I make intentional mistakes, like those rudimentary and rookie mistakes, so that that the viewers can also have some sense of like being in the same sort of situation. Like we all do those rookie mistakes, and sometimes we don't understand what is wrong. And if you see those mistakes and those compilation errors or runtime errors or whatsoever, then you might see that, hey, the compiler is trying to tell you what is wrong, and sometimes you need to basically listen to that and try to find the cause of that issue. But so only so much of talking, but if those 2 reasons are enough for you, please continue watching this video. I'm going to jump into my terminal here. I have, again, as usual, 2 terminals, one in the background and one here. Both of them are fired with OpenFOAM 24.06. In this case, Filippo had OpenFOAM 12, but more or less, if you understand the logic behind the things that I'm going to discuss today, then basically a change of version is basically, you can find your own way. Like with the things that we discuss here, certainly you can find your way. So as I said, so much of talking. Now let's just jump into some implementation and stuff. So we said we want to implement turbulence model, and namely k epsilon. We're going to pretend that that's a new model. So at the end of the day, after the compilation step, we need a test case to test that. So let's go to our tutorials. I'm going to go to incompressible, and I'm going to grab for, let's go with k epsilon. You see that bunch of tutorials. I can go with, I don't know, any of them, but you see that I have always, my heart goes with Pitts Daily. So let's take this, for example, here, but any of the examples using k epsilon should be fine. So this is the test case. I'm going to take the absolute path of that. And by the way, I have this test case alias. So if I hit the return key, check the PWD, it says that this is my 24.06 version. At the runtime directory, I created a directory called turbulence model. And then inside a directory called test case, I'm going to copy my test case. And this is my Pitts daily. Let's take a look at control dict. You see that it starts with latest time. The end time is 0.03, and with a time step of 0.0001. It's too much. So I'm going to make 2 zeros and 1. So this is like 10 time steps. I'm going to make this as time step. I'm going to make it every time step, and ASCII is fine. Adjust. I don't want to adjust my time step. I'm going to save that. I'm going to say block mesh. And I'm going to say pimple foam and see whether the case runs out of the box. The simulation runs out of the box. Results are written here. Everything is fine. So I'm going to say foam list times, because we don't have actually an all clean and all run in this case. I don't know. Anyways, so I'm going to go to constant. Now we're going to do an experiment, and we're going to go to turbulence properties. I'm going to go to k epsilon, and I'm going to say type a, I don't know, a garbage name in there. And I'm going to say pimple foam again. So you see that if I do that, I'm going to get sort of this error. There's no undefined symbol in here, but you see that it says that the RAS model is not basically defined, like not, it's unknown to me. And the valid ones are these 21 possible options. And this is the list that you get in here. So this is a nice feature of OpenFOAM because it gives you a direction that what things are possible within the things that you want to change. And then you see that the same sort of file is basically complaining, the rasmodel.c, but in this case, not at line 155, in the case of openfoam.org, but here is line number 158. So there we go. This is our first step. We have a test case, and we can implement now our, let's say, turbulence model, and then come back to this. So let's go back. Let's go to the source code, and I want to look for k epsilon, because this is sort of the fictitious turbulence model that we want to use. It's a 2-equation turbulence model, addition of 2 equations, one with turbulent kinetic energy and the other one with dissipation rate. So now, so I'm going to look for this, and you see that it happens in, so one is in, I don't know, optimization, whatever. You can also check that one, but this is the main focus that we want to have. So turbulence models, RAS, and k epsilon. So let's go in here, RAS, and let's go to k epsilon. And this is the source code of k epsilon. So I'm going to copy that. I'm going to code. This is the second alias I was talking about. Code basically points into run directory of 2406, turbulence model, not inside the test case, but inside the source code. So here I want to put my k epsilon directory, and I want to move this to k epsilon, but I want to say custom k epsilon. And in custom k epsilon, I want to move the k epsilon.h to k epsilon.h, but this time I want to add a custom in the beginning, and here I want to add the .c. But you see that inside the .h, we have everywhere k epsilon happening, like you see everywhere k epsilon. But I need to change that. So I'm going to grab minus RL for k epsilon, and then I'm going to pipe that into xargs, and I'm going to use set for this with in place mode, and I'm going to do this, and then I want to substitute k epsilon with custom k epsilon, and I want to do it globally. So if I go back to this header file, you see that we have in all those instances, now we have custom k epsilon instead of k epsilon. So very fine. Now we have our source codes .c and .h file, but we don't know how to compile that, because usually in OpenFOAM, when you want to compile a library or whatever, you need a make file, and then you need two things in it. You need files and options, right? So let's go back and figure out how OpenFOAM does that. Take a look at here. If I go back, there's no makefile in this directory, right? I go one step more back. There is a makefile actually in here. So I'm going to go inside make and files. So if this makefile is the makefile that compiles my k epsilon, there has to be an instance of k epsilon.c in here. You see that pattern not found. So this means that this makefile is not actually the makefile that compiles whatever inside this RAS directory. That's very, very important. Now I'm going to go back. I'm going to grab. So what does it mean? It means that the k epsilon has to happen somewhere in a makefile or in a macro file, as we have seen also in the case of writing our own equation of states in the previous episode of Learning by Doing OpenFOAM. So let's search for k epsilon itself. If I search for k epsilon, you see that it happens in a bunch of places. So one is phase compressible, incompressible, turbulence. You can ignore these because we have already watched these. We have already inspected the turbulence model directory. And there's also a compressible part. So if you remember from the previous episode, writing our own equation of state, you saw that equation of a state was just a piece of the puzzle. And there were like other factors that we depended on it. So in turbulence models, the same scenario happens. Probably it's less messy and less complicated. And in this case, you need to see what kind of solver you are targeting for. When I took that example in the tutorial cases, it was the pimple foam example. So the solver that we are aiming for is a pimple foam, which is an incompressible solver. So what we are aiming for here is actually incompressible. But it could be one of those multi-phase solvers, or it could be one of those compressible solvers. So it depends on what you are aiming for. Again, I'm trying to give you like a sense of making sense of things or getting the right direction. So since we are using pimple foam, we're going to focus on this incompressible directory. So let's go inside this incompressible, and I'm going to grab that, and you see that it happens in cd turbulent transport models, and here in turbulent transport models.c. So this is where that k epsilon is happening. You see that again, you include the header file, and then you use something which looks like a function, but similar as I said in the previous episode, but this is actually a macro. So I'm going to copy that, and I'm going to go back. So by the way, all the magic is happening within this source file in here, the turbulent transport models.c. So I'm going to grab that. If I do that, you see that it happens in .c. Of course, that's the instance we found already, but in the .h, if you take a look at the .h, if I show you that, make RAS model, and then it takes the type. And the type in that case was k epsilon. And you see that it uses another, we're going to go down the rabbit hole. It's using another function called make templated turbulence model. And it takes 3 arguments. One is transport model and compressible turbulence model. And then it's RAS. And then the type, in this case, is going to be k epsilon or custom k epsilon. So I'm going to grab for that function, make templated turbulence model. You see that it happens only in this header file. That's not what I want. I grab it again here. You see this is the only instance that it happens. I'm going to go back again. I'm going to grab again. You see that now it happens in turbulence models, make turbulence model.h. You see, if you go inside and take a look at this make turbulence model.h, if you look for that make templated turbulence model, you see that it's defined here. So it's another macro, which gets the base model. That was that long name of, I don't know, incompressible turbulence model something. And then S type, which was RAS in this case. And the type, which for our case is k epsilon or custom k epsilon or whatever turbulence model that you want to compile. And you see that the magic that it does, it basically puts these things around. It puts it in namespace of foam, and it puts this in S type, which was RAS. So it puts it in RAS models in that namespace. And then it has a bunch of like type diffs and stuff, and it adds it to the runtime selection table. So you see, this is how basically, as I said, also in the previous episode, when you're working with templates, and OpenFOAM uses heavily templates in the source code, so you need to take care of those specific instantiation of types that you are working with. And the way that OpenFOAM basically deals with that is the usage of these macros. Things like the things like you saw, for example, in writing your own equation of state, or in this episode that when we are talking about writing our own turbulence model. And this is how it basically automates the stuff. So now we basically went down the rabbit hole, and we know that where the compilation of this k epsilon model is happening. It actually happens in that source file in incompressible right here, and it happens by compilation of this turbulent transport models.c, where we call this macro when we say make RAS model k epsilon or custom k epsilon. And so this means that this directory of incompressible should be of our interest. So now I'm going to copy that, and I'm going to go back to my code, and I have my thing here, and I'm going to copy that incompressible to here. So now let's go here and take a look at files. You see that a lot of things are being basically compiled here. You see that other than that, so a bunch of these things are basically added here, like Q zeta and KL omega. You see that there were like, when I typed something garbage and then it dumped out like 21 models, and you see that Q zeta was also one of them. But when you take a look at RAS models here, you see 1, 2, 3, 4, 5, 6 of them here. But there we had 21 models. So it seems like not all the source files are in the same place. And that is also the case because K epsilon itself wasn't actually in incompressible, but it was in turbulence models and in ROS. So K epsilon was actually here. And so a bunch of the ROS models are separated and they're located in turbulent transport models and in ROS here. And these are those 6 or 7 models. I don't know. It was 6 of them, I think. This Q zeta and stuff like that. And there are also other models like I can show it later that they're located at different directories. And that is actually going to be one of the leads that we figure out what is the problem, a problem that I want to show right now. So let's get rid of these stuff. Let's get rid of all these stuff because all we want to do is to put this at user because you don't want to. By the way, I copied that incompressible directory. I could have done my changes here, but probably you don't want to do that. That's the last thing you want to do because you don't want to mess around with the original source files of OpenFOAM installation that you have. So I copied that into my run directory into a specific folder. So now I changed this one also to user libbin because I don't want to mess up my original library files. I'm going to change this name to, I don't know, custom K epsilon turbulence model. So this looks fine to me. And now the only source file that we are compiling is actually this turbulence models.c. So I'm going to go back here. And I'm going to get rid of all these laminar models because we don't care about these. We want to have a custom K epsilon model. So I'm going to get rid of all the RAS models and all the alias models that we have. So the only thing that I'm remained with is just this one. I'm going to add this as custom. Oops, if I can type that only. Custom K epsilon. And here also, oh, I think I messed it up again. Okay. Custom K epsilon also here. So if I now try to compile that, it should basically give me an error, right? So let's take a look at it. So you see that bunch of stuff, it couldn't open them, and then we have dependencies, and there's this turbulence model.h, you couldn't find it, and then if you go back and find, for example, the name of turbulence model.h, you see that it happens in turbulence models. And if I go to make and options, you see that this is like dot dot notation. So from the perspective of this incompressible directory, dot dot means here, and then turbulence models means here. So now I don't have access to that because I have copied that thing into my own run directory. So I need to use sort of lib and then source, and then it was, I think, inside turbulence models, and then inside turbulence models again, and then ln include. But if I do vclean and vmake, again, we're going to have an issue because we are saying that we want to compile this custom K epsilon, but we don't know where that resides. So we need to go into make and then options again. We need to add another line here. I'm going to change that to foam run because we put it in the run directory. And then we put it, I think it was turbulence model, and then it was in source code, I think. And then it was under custom K epsilon. I believe that should be the correct path to that thing. If I made a mistake, so I should get an error. If not, then this should compile. Let's see, moment of truth. So now you see that it compiles. And to check that, I'm going to basically show you the foam user libbin in here. And you can check that this lib custom K epsilon turbulence model is actually the library that we compile. So it is actually there. So let's go back to our test case and let's go to pits daily and try to use the pimple foam in there. So of course it's not going to work still. We have 21. You might say, hey, you forgot to add this to your system and control dict because we need to add our library here. And we should say this is a custom K epsilon turbulence. I think this is how we called it. And I'm going to, don't forget this, to put the semicolon. And then if I do the pimple foam again, you see that it's not going to change. It still says 21. So this is sort of similar situation where Filippo had, but it's not exactly as because he had like an undefined symbol, but here we don't have any undefined symbol. But still, we didn't get any compilation error when we compiled this turbulence model. But still, we're getting the same thing, that at runtime, basically we cannot select it from the runtime selection table because perhaps something went wrong. And of course, something went wrong. Let's take a look at this. K epsilon Lopez da Costa. Let's go back and, I don't know, like probably we should go back again. Grab -RL for that. If I do that, you see that it happens in atmospheric models, turbulence models, atmospheric turbulence models, atmospheric turbulent transport models. So let's go there. And you see that there is a ROS directory here. And if you take a look at it, that's the turbulence model. And this is another turbulence model, KL. This is also listed here. This one also listed here. So these are like two extra turbulence models, which are not in the regular incompressible or the turbulence model directories, but rather in an atmospheric models directory, which is separate from those. Now, so if you take a look at this atmospheric turbulent transport models.c, you see that we add this header file, and then we have nothing else. We just have the include statement, and we have the make ROS. But if I go back to my code in incompressible, you see that in turbulent transport models.c, I kept all these junk up here, defined turbulent model types. Some extra sort of macros that we are using here. I need to get rid of that, because one example in OpenFOAM is that, oh, you don't need anything up here. You just need the include statement of that .h for the turbulent transport models, which we have it here, and then you don't need anything else. You just need the include statement, and you just need that macro that basically instantiates that specific type for you. So that's basically that detective thing that I was talking about. So now let's take a look at, if I save this now and I go back and I say vclean and vmake, let's take a look at this. But previously it didn't give me any compilation error. So this is sort of a similar situation to what Filippo got. But probably his case, probably some other error was happening. You see that I don't get any error, so I'm going to go to test case and in pits daily, and I'm going to say pimple foam. And you see that this time it's not 21, but it's 22. And you see that custom k epsilon is actually added to the runtime selection table. That's absolutely nice, right? So I can go back to constant turbulence properties, and then I can, I don't know, probably change this to custom k epsilon, and I can run pimple foam, and then you see that simulation runs perfectly fine. And you see that the ROS model which is selected is indeed custom k epsilon. And I can also show you, like the previous video, where the magic happens, that voodoo magic with those macros when they expand. If you go back to our code, and here when I say vclean and vmake, you see that it dumps out the compilation command in there. It's a very long thing. We are going to copy that. And let's paste it in here, but we are not going to create an object file out of that. We are going to take a look at the result out of the preprocessor. So I'm going to redirect it into log.c, and I am going to add a -E here to get the result out of the preprocessor, and take a look at this log.c. Take a look at custom k epsilon in here. So this is, so how many files are we compiling? Take a look at here, only one file, and that is turbulent transport models.c. Take a look at this log.c. After it, so this source file, if you take a look at here, so this is the one that we are compiling right now. What does it have inside? It's just two include statements and one macro function here. That's all it has. But after, just check this, how many lines do we have here? It's 46 lines at most, with all those comments and stuff as well. Take a look at the expansion after the preprocessor does its magic. This is the end of the file, 258,984. So that's what happens to your basically include statements and everything, that your macro expansions and everything. So I'm going to check for custom k epsilon, and you see that this is where that voodoo magic happens, those direct instantiations and addition to the runtime selection table that happens here. And if I hit the next key, and then you see that this is the actual code of the custom k epsilon that is basically being compiled. So this is how the compilation happens. It looks like sort of like a voodoo magic, but this is how OpenFOAM manages it with the help of macros. There is one last piece of thing that I didn't talk about. And to stand technically correct, I'm going to add this. So if you take a look at this atmospheric turbulence models, if you go back, there's a make file here, right? And take a look at files. So that basically atmospheric turbulent models.c is added here. So the compilation is happening here. So I am going to check the make and options in this case. You see that those atmospheric models are happening, if I say constant and turbulence in custom, if I say, I don't know, some garbage, and if I try to run PimpleFOAM, you see that these things are basically added here, and this is one of those, and the KL is also one of those atmospheric models. So you see these two are in the same spot as custom k epsilon and as other models like q zeta, which was inside the incompressible directory, right? But here, take a look at the libs that we are linking against. We are linking against the incompressible turbulence models. And what is this incompressible turbulence models? It's actually the one which was in turbulence models and incompressible directory in this make and files. You see that this is incompressible turbulence models. So whatever you have like q zeta, kkl omega or whatsoever, they're like bundled all together. So if you want to expand your library, your turbulence library with the pre-existing ones, to stand technically correct, that you should also add this into your make files. So that means that I need to go to make and options, and here probably I also need to add like something like this, and instead of transport models, I need to add turbulence models, or sorry, incompressible turbulence models, yeah. So that's why I need to add here. And if I say vclean and vmake, you see that it works. But why we didn't get any errors? Like, because PimpleFOAM is already knowing about that library. We are using PimpleFOAM solver. So let's take a look at incompressible. Let's take a look at PimpleFOAM. And let's take a look at make and options. And you see that here we are linking against the atmospheric models, and we are also linking against all the incompressible turbulence models. So now you sort of understand that if you want to expand whatever is existing in OpenFOAM to stand technically correct, you should also add that, just like similar what OpenFOAM basically does with its own atmospheric turbulence models or whatsoever. They do this as well. Like we saw that in options, that they are linking against incompressible. Oh, this is a different directory actually. It was in atmospheric models. Here in turbulence models, no, actually in make and options, we see that we are linking against this incompressible turbulence models as well. So that's basically how you need to implement your custom turbulence models. So I try to give you sort of a direction, and I hope that this video is actually useful to you, and hope to see you in the next one.